to have the maximum hydrocarbon recovery in the least time and with the least expense. And also all the volumetric and the phase diagrams that are in the PVT test, they are affected by two factors, which are pressure and temperature. And getting an accurate data about these properties of the hydrocarbon of an oil well will give us a maximum production of the reservoir fluid or hydrocarbon. The first thing I want to talk about is bubble point determination. So bubble point determination is determined when we have a flash liberation test. So basically, in this test, we get a sample from the downhole of the reservoir or from the accumulated gas on the surface. Oh, can you go there, Omar, please? Oh, thank you. So we get a sample from the downhole reservoir or from the accumulated gas from the surface, and then it's around 100 centimeter cube, and we put it in a cell. Basically, the cell is a high temperature, high pressure with a positive displacement mercury. So as we remove the mercury from, before this, we put the oil or the sample into the cell, and we're removing the mercury gradually to give us the pressure drop and volume change. And this is called a flash liberation test. I will talk about it more in the next slide. But before this, bubble point is important for two reasons. One of them is to know the hydrocarbon properties and the behavior, and the other one is to determine the driving mechanism. I'll also talk about the driving mechanism in the next slide. We also have two tests that can detect the bubble point. The first one, as I mentioned, is a flash liberation test and differential liberation. So the first one is flash liberation. Basically, flash liberation is a sudden drop in pressure. And the most important thing about flash liberation, at the end of the test, gas and oil will remain in contact. They do not separate. So the first thing, as we can see from the picture, we have pressure initial, which is oil and mercury. As we are removing the mercury, the pressure is dropping. It's dropping to a point where a gas bubble is emerging. At this point, we'll call it a pressure bubble point. It's the point where the first gas is emerging from the or passing from the liquid to the two-phase region. And in flash liberation, we have three different mechanisms. The first one is called pressure, where the pressure of the reservoir is equal to the pressure of the bubble point. When this happens, when this situation happens, a gas gap will exist, and this one is naturally exists. So basically, a gas gap is located at above of the oil, and its main purpose is to put pressure on the oil and rise it to the surface. That's the point of the gas gap. Another situation is where we have a pressure of the reservoir is under the bubble point. So in this case, where we have the pressure under the bubble point, we have gravity segregation. Basically, gravity segregation is a gravity field that makes a secondary gas gap. This also helps. This secondary gas gap is not natural. It's actually made by the field of the gravity, and it helps to rise help rise the oil into the surface, and it can recover up to 40%, I think. No, 70% actually. And the pressure, I forgot to tell you, the pressure that is equal to the bubble point of the reservoir has a recovery of 40%. And the last situation is we have pressure above the bubble point. Basically, this is not good because we have undersaturated oil, meaning that the oil has a very small amount of dissolved gas. And when we have undersaturated oil, we don't have a gas gap. so that's problem. It doesn't help the oil to go to the surface. So a solution is to for this is called enhancement method, which basically using natural water to push or to put pressure on the oil and rise it to the surface. And the second test is called differential liberation. Basically, flash liberation and differential liberation are very similar. They have a very slight change. The differential liberation is drop in pressure gradually, and at the end of the differential liberation, the gas and oil will no longer stay in contact. So if you look at the picture, we can see that differential liberation happens after bubble point, while the flash liberation happens before the bubble point. If you look at the first step of the picture, it's oil and mercury. And well, when it's reached the bubble point, we know the gas emerging from the cell. So when that happens, we're removing the mercury with a constant pressure, and we will do this until we will no longer have gas in the cell, and we'll only have oil and mercury in the cell. The importance of differential liberation is for measuring reservoir fluid volume at a standard temperature. And this is a phase diagram. So basically, we have two phases of diagram. This is a multi-compound system. We also have another one called a single compound system. Basically, the difference is in single compound system, we don't have a situation where we can have a liquid and gas coexist together. However, in multi-compound system, you can see that we have an envelope. It's basically this circular, almost circular layer that which gas and liquid can coexist together. And basically, the phase diagram is a relationship between pressure and temperature that has a liquid and gas coexist together. We also have some other points in phase diagram. The first one is dew point. Basically, dew point is the opposite of a bubble point. In dew point, the first droplet of liquids emerge passing from gas region to two-phase region. While in bubble point, the bubble gas is emerging and passing from the liquid region to two-phase region. And then we have pre-condensatherm is the highest temperature where liquid and gas can coexist together. And we have a pre-condenser. This is the highest pressure point where gas and liquid can coexist together. And this is one type of phase diagram. The first one, I'm going to start with the right one. It's called the gas reservoir. As you can see from the right picture, the whole gas is actually it's all located in the gas region. We have two parts of gas reservoir. We have dry gas and we have wet gas. The first one is dry gas. We call it dry gas because, as we can see from the vertical straight line, the whole it's all located in the gas. There's the absence of liquid hydrocarbon. Therefore, initially, the dry gas will only produce gas. It has no liquid in it. However, when we talk about wet gas is basically this slope that is located in the separator location. This is the part where we no longer have the absence of liquid hydrocarbon. We actually have liquid hydrocarbon, and besides gas production, also we get liquid. And the other one is the left one is called the retrograde gas. Basically, retrograde gas is the process where we have saturated gas passing the dew point, and a large amount of oil will condense. This process called retrograde gas. Well, we have a condensation of a large volume of oil. And the last one is the oil reservoir phase diagram. The first one, if you can see, we have the first line or the first point is starting as undersaturated oil. Unsaturated oil, as I mentioned before, is basically a liquid that has a very small amount of dissolved gas, or oil with a very small amount of dissolved gas. And you have saturated oil. This is the part where the maximum amount of gas is dissolved. So basically, it's oil that contains the maximum amount of dissolved gas. And as it goes below the bubble point, they go to the separator, and we will have not just liquid or oil, we will also have gas and oil. Gas is actually will come out at the surface of the reservoir, and it will come out from the solution. And the following slide, my colleague will present it.
My name is Omar Imad, and I'm going to talk about the reservoir to surface volume relations. There are three more important parameters that relate the surface volume to the volume of the reservoir, and that helps to determine how much hydrocarbon is in place. The oil formation volume factor is the amount of oil that is needed to produce 1 barrel of stock tank at standard condition, whereas gas formation volume factor is the amount of gas that is needed to produce 1 cubic foot under standard conditions, where the saturation oil gas ratio (RS) is the amount of the solvent that needs to dissolve into 1 stock barrel tank. And these parameters are obtained through a series of differential and sequence of flash liberations. As well as we talked about, differential liberation is the same as flash liberation, but the differential liberation gas is extracted after the bubble point, and is replaced by mercury. And in this to get these parameters, we need to do 48 reductions until we reach standard conditions. Then we would record the volume of the oil residue, wherein the flash liberation is mainly used to determine the optimal pressure at each stage of the separators, and the optimal number of stages within the separator. And at the flash liberation, we will use an inert gas that will go through a small scale separator, where pressure and temperature will be altered at each stage, and the volume of oil and gas will be measured at each alternation. The compositional analysis is important for determining how much is the market value of that oil well, basically how much kerosene or bitumen, crude oil, light crude oil is going to be produced from that oil well, and how and where the crude oil will be refined, because light crude oil will be refined through distillation, while heavy crude oil is going to be refined through high temperatures. The best way is the gas chromatography, where hydrocarbon samples are burnt and put into injection ports, and these injection ports go through columns that have porous adsorbing material. After that, these gases will go to the detectors. There are two types of detectors: the flame ionization detector, which is made of air and hydrogen, and it burns the sample. It burns the sample, and there the change in flame conductivity is proportional to the amount of ion electrons produced from that hydrocarbon, and they will show up as chromatographic peaks, where the temperature conductivity detector is about how much the heat loss is reduced when an inert gas and the compound go over a filament such as platinum, tungsten, or nickel, and how much they increase the pressure and change the resistivity. The changes in resistivity will be recorded as chromatographic peaks. Here we can see the detector response against time, and the retention time is the time that is needed for the compound and the injection port gas to go through the column. Also, the area under these peaks represent the percentage concentration of that compound. The reservoir fingerprints GPC with its gel permeation chromatography allows the analysis of both residues and light oils of similar fingerprints. There are non-communicating production zones, which are dissimilar fingerprints of the same oil sample from the same well at different depths. While different accumulations are dissimilar fingerprints from two oil wells at the same field. The equation of states helps provide information about fluid properties and behavior when they have not been tested at the PVT lab, such as modeling, let's say. And one simple equation used for simulation is the PV equals Z nRT, where Z is the compressibility factor relating real gas to real gas to ideal gas. And an equation of states has to be tuned against the real experiment PV data because equation state has parameters that has to be fulfilled through PVT data. The hydrocarbon composition is, so most hydrocarbons are made of carbon and hydrogen, and and any other additions are meant as impurities. They are classified into 18 different series based on whether they are open chain cyclic or saturated or unsaturated, and the amount of series determines, the amount of carbons in the series determines the properties. There are alkanes, which are saturated hydrocarbons made of single carbon bonds, and they're open chain. They start with methane, and the first four gases, the first four are under standard conditions are gases. The next 13 are liquids, and anything above C18H38 is solid. They are mostly stable. Cycloalkanes are also saturated hydrocarbons that are stable and form closed rings. The first in the list comes is cyclopropane, which is C3H6. RNAs are unsaturated hydrocarbons that make rings with double carbon bonds, and they mostly produce fragrant compounds, and they are unstable but not highly reactive. Fluid analysis at the well site. Sometimes PVT labs are not accessible, so we have to have fluid property estimation. Although it does not measure the bubble point, it provides a real estimation of compositional analysis and fluid properties that can tune up with the equation of state. It's mostly made of two chromatographical ports and one personal computer. It has two columns with each one that has its own TCD with it. So first of all, the injected port goes through the column, and lighter gases such as hydrogen, oxygen, and nitrogen. Oxygen, nitrogen, and methane are extracted through a series connection. After that, the series connection changes to a parallel connection where C2 compounds to C5 compounds are separated. And anything more than C6 plus, which is any compound with six carbons or more, are back flushed as leak pumps. Downhole sampling happens after well site conditioning. Conditioning is important because we want to have the oil reservoir. The reservoir fluid is the same as it had to have the same property as it goes through the oil well bore. At least 3 samples must be taken, around 10 to 20 liters of gas and 600 centimeter cube for oil. These samples will be validated later on in the PVT labs. Sampling procedures depend on the reservoir fluids as well. And the sampler tool here is actually has pressure gauges on each wire line. And it has a clock chamber which opens and let the gas come out slowly at constant pressure. Then an air chamber, which is a piston chamber that is responsible for closing the chamber again. Thank you.
I think this was a great presentation, and you touched some advanced concepts also. So, and what I think that now your information is almost equal to mine in this subject, which is very good. And so thank you for such
Thank
a
you so
nice
much.
presentation. Okay,
Thank
please
you
let's
so
go to the
much.
next one.
Okay, thank you so
No
much.
questions before we are running out of time already. So just close it so that other one can come. Please, anyone else? Any other group? Okay, the rest of the groups, I would like to ask them to put a video on the Google Classroom.
Sir,
If they are not,
aren't we
yes.
the class time? Like we finish at 3:15 and we have other classes. I mean,
Yeah, okay, you can go. Those who finish, they can go.
okay, thank you so much. So we should just record ourselves during the presentation and then send it to you through class.
Yes.
Right.
Yes.
Thank you so much, sir.
Okay. Okay, so we finish this lecture here, and those who couldn't do it, please submit online on a video lecture as a video lecture.
Sir,
Okay.
excuse me, where can I submit it, please?
On Google Classroom.
Google Class. Okay. Thank you so much.
Okay.